Next story. Optimizing the location of EV fast chargers with machine learning. General Motors, GM, is revolutionizing the electric vehicle, EV, charging landscape with the strategic use of machine learning. As the automotive industry shifts towards electrification, GM is leveraging AI to select optimal locations for installing new DC fast chargers. By teaming up with Pilot Company, GM plans to establish 2,000 fast chargers at Flying J and Pilot travel centers across the U.S. GM's Chief Data and Analytics Officer, John Francis, emphasized the importance of AI in simplifying operations and enhancing customer experience. While many companies chase after flashy AI applications, GM focuses on practical solutions that drive meaningful business outcomes. The challenge of selecting from over 750 travel centers spread across 44 U.S. states and 6 Canadian provinces led GM to employ machine learning algorithms. Through data aggregation and analysis, GM's data scientists combined various geographic datasets, including existing charger locations, traffic patterns, and travel center locations. This holistic approach enabled GM to pinpoint the ideal sites for new chargers, considering factors like foot traffic, infrastructure costs, and market saturation. The scale of data involved, with billions of data points, necessitated cloud platforms and distributed computing clusters. The successful deployment of the first 25 sites in 2023, featuring 100 charging stalls, demonstrated the efficacy of GM's AI-driven approach. By the end of 2024, GM aims to have 200 operational charging locations, facilitating the growth of EV infrastructure and supporting the transition to electric mobility. This targeted expansion aligns with GM's commitment to enhancing accessibility and convenience for EV owners nationwide. The application of machine learning in selecting charger locations not only optimizes resource allocation but also underscores GM's dedication to innovation and sustainability. As the automotive landscape evolves, GM's proactive adoption of AI showcases a progressive mindset focused on shaping the future of electric transportation. With data-driven decision-making guiding its EV charging network expansion, GM is paving the way for a more connected and efficient electric vehicle ecosystem. In a world inundated with AI hype, GM's practical and impactful use of machine learning stands out as a shining example of how technology can drive real-world benefits. By leveraging AI to strategically deploy EV chargers, GM is not only revolutionizing the electric vehicle infrastructure but also demonstrating a commitment to enhancing the overall EV ownership experience. Source: Ars Technica. Next story. Boosting cellular immunotherapy development with machine learning classifier. In a groundbreaking discovery, scientists at the German Cancer Research Center have revolutionized the development of cellular immunotherapies. By harnessing the power of machine learning, they have devised a classifier that accelerates the identification of tumor-reactive T-cell receptors, slashing the time required for this crucial step in cancer treatment in half. This advancement is a game-changer in the realm of personalized cellular therapies, offering hope to patients battling various types of cancer. Traditionally, the process of creating personalized T-cell therapies for cancer patients has been arduous and time-consuming, taking a minimum of 6 months. The initial phase involves isolating tumor-infiltrating T-cells from a patient's tumor tissue and identifying T-cell receptors that can target and destroy tumor cells. This step has been likened to searching for a needle in a haystack, as it relies on knowledge of specific tumor mutations, making it a race against time as tumors continue to evolve and spread. The team of researchers, led by Michael Platten and Ed Green, has developed a novel technology that streamlines this process. By combining single-cell sequencing data with machine learning algorithms, they trained a classifier called Predict-TCR to predict tumor-reactive T-cell receptors with remarkable accuracy. This innovative approach eliminates the need for prior knowledge of tumor epitopes, making the identification of tumor-reactive T-cells much faster and more efficient. The impact of this technology is significant, as it cuts down the time required to identify personalized tumor-reactive T-cell receptors from over 3 months to just a matter of days, irrespective of the tumor type. The classifier, with its 90% accuracy rate, offers a versatile solution that can be applied across different types of tumors and cell sequencing technologies. The implications of this breakthrough are far-reaching, with the researchers aiming to integrate this technology into clinical practice in Germany. To support further development, a biotech startup called Cellular has been founded, with Predict-TCR serving as a cornerstone technology, This cutting-edge research has been published in the prestigious journal Nature Biotechnology, marking a significant milestone in the field of personalized cancer therapies. As we witness the convergence of machine learning and immunotherapy, a new dawn emerges for cancer patients, where treatment timelines are condensed, and hope shines brighter than ever before. Source: Medical Express. Next story. Challenges in automatically detecting fake news. In a world where misinformation runs rampant, the quest for an automated solution to detect fake news seems like a promising endeavor. Many have turned to machine learning for answers, hoping for a simple and reliable tool to distinguish truth from falsehoods with ease. Yet, as experts from the Rensselaer Polytechnic Institute warn, the reality is far more complex. Dorrit Nevo and her team delved into the realm of automated fake news detection, uncovering a web of challenges that these tools face. Biases, issues with generalizability, and the unpredictable nature of news content all pose significant hurdles. The researchers caution against blindly relying on these models, emphasizing the ethical concerns that arise from their deployment. One of the key insights from the study is the critical role of ground truth in training and evaluating these detection models. The labels assigned to news items can shape the model's perception of reliability, yet the process is not immune to human error and subjectivity. This reliance on subjective judgments can inadvertently perpetuate biases in the system. The researchers stress the importance of a diverse team in establishing ground truth, encompassing not just programmers but experts from various fields and the general public. This inclusive approach is seen as vital for ensuring the fairness and accuracy of the detection models. Moreover, the ongoing re-evaluation of these models is deemed essential, as the landscape of fake news continues to evolve. As the study highlights, a one-size-fits-all solution may be an elusive goal in the realm of fake news detection. Instead, a combination of approaches, including media literacy and targeted model applications, could offer a more robust defense against misinformation. The researchers advocate for a cautious, transparent, and thoughtful approach to developing these tools, given the high stakes involved in combating fake news. In a world where the lines between truth and falsehood are increasingly blurred, the quest for reliable detection mechanisms is more pressing than ever. By navigating the complexities of automated fake news detection with diligence and inclusiveness, we may inch closer to a future where misinformation holds less sway over our society. Source: Tech Explore.